intermolecular forces of attraction between molecules is just like the interpersonal forces of attraction between you and your ex. Very weak and very easy to break. That's why break up already. He or she became your ex. Che, bonding is very hard. All you have to do is to be confident, genuine, and be nice, and you very soon will find yourself a girl or boyfriend, right? Che, I mean the other bonding. Oh, you mean the 50 Shades of Grey bonding? Okay. For that, you just have to tie up chemical bonding. The difficulty of this topic is 0 out of 10.
Nice.
Even the meme guy here says that it's easy. You are an ape if you even lose a single mark on this topic in exam. Because this topic follow an extremely predictable question and answer scheme in exam. So, listen up if you want your monkey brain to fully master this topic, okay? Chemical bonding. Why is so easy? Yes, this is what you'll be asking me after watching this whole video. Okay? Let's start watching this video. Alright. In school, you learn 3 types of chemical bondings. Ionic bonds, covalent bonds, and metallic bonds. For ionic bonds, it's basically bonding between metals and non-metals. The description of these ionic bonds is strong electrostatic forces of attraction between oppositely charged ions. Let's look at an example of an ionic bond, shall we? Okay, in this example is sodium chloride. Sodium chloride is an ionic bond because sodium is a metal and chlorine is a non-metal. So metal bond with non-metal is an ionic bond. So easy, right? This is how an ionic bond works. The sodium in this case will transfer an electron over to the chloride ion, non-metal. So because the sodium atom transfers an electron over to the chlorine atom, the sodium loses a negative charge. So it becomes sodium plus. And the chlorine atom, it gains a negative charge. So it becomes Cl minus. We know that unlike charges attract. So this sodium plus will attract this Cl minus. And this very attraction between positive and negative charge is called the electrostatic forces of attraction between sodium ions and chloride ions. That is why we call this an ionic bond. Get it? Next, covalent bonds. Covalent bonds are basically bonds between non-metals and non-metals. Think of things like hydrogen, H2, CO2, CO. So covalent bonds are basically the sharing of electrons between atoms. An example over here is this H2, okay, hydrogen bonded with another hydrogen. So one hydrogen atom has an electron, as we know from the periodic table. The hydrogen atom will covalently bond with another hydrogen atom to share 1 electron each to have a total of 2 electrons. So basically this sharing of electrons is covalent bond. Get it? The description for covalent bonds is just strong covalent bonds. Next, metals. The bonds between metals is of course metallic bonds, and the description for metallic bonds is strong electrostatic forces of attraction between positive ions and C of delocalized electrons. This is an example that you can see over here. Positive ions, in this case, N plus, N plus, N plus, N plus, with C of delocalized electrons around here. It's basically the attraction between N plus and E minus, N plus and E minus, which makes a metallic bond. And it's called electrostatic forces of attraction because it's the attraction between positive and negative charges. Got it? Next, we need to know the naming of these structures. For ionic bonds, it's called giant lattice structure. For covalent bonds, there's 2 types of structures, simple molecular structure and giant molecular structure. And for metallic bonds, it's called giant metallic lattice structure. Last but not least, we need to know the physical properties of these different structures and bonds. Number 1, ionic bonds have high melting and boiling point. Number 2, ionic bonds are soluble in water but insoluble in organic solvents. And number 3, ionic bonds can conduct electricity only in molten or aqueous states because of mobile ions. So how do I memorize all these physical properties? Very simple. There's a memorizing or remembering technique called anchoring. So what I always do is I always anchor ionic bonds to sodium chloride, which is our table salt. and covalent bonds the simple molecular structure to hydrogen and giant molecular structure to diamond. I got this information through Google. It shows that sodium chloride has a melting point of 801 degrees Celsius. That's super high. That's why sodium chloride, or table salt, has a very high melting and boiling point. Next, this is how sodium chloride or table salts looks like when you dissolve them in water or when they are liquid state or molten state. Ionic compounds can conduct electricity in aqueous and molten form. Because just being in aqueous or molten form, the ionic bonds are broken and they float around in the solution like this as shown on the screen. So they float around as Na plus Cl minus ions and they become mobile ions. That's why as mobile ions, they can conduct electricity. Got it? Easy. Let's look at the physical properties of simple molecular structure and giant molecular structure of covalent compounds. So simple molecular structure is very simple. I always anchor hydrogen. The physical properties here are directly opposite of the physical properties in ionic bonds. So simple molecular structures has low melting and boiling points. They're insoluble in water, but soluble in organic solvents, and they do not conduct electricity because they do not have mobile ions or electrons. As for giant molecular structure, we think of diamond. Common sense, obviously they have high melting and boiling point. Obviously they are insoluble in water or organic solvents. And obviously they do not conduct electricity except for graphite because graphite has mobile electrons. So I need you to go open up the textbook and read up about diamond, silicon dioxide and graphite. Physical property of graphite is slightly different from the other two because of some of its special properties, and you just have to read it up on the textbook, okay? Simple molecular structures in covalent compounds has low melting and boiling points because it has weak intermolecular forces of attraction. So you know that in covalent compounds there are two types of structure. There's simple molecular structures and there's giant molecular structure. The only difference is that simple molecular structures has weak intermolecular forces of attraction between molecules, whereas giant molecular structures is just a giant structure that has atoms covalently bonded to each other. Okay, so in this example, as you see on the screen, is hydrogen molecules between each other does not have covalent bonds. As you can see on the screen, it only has weak intermolecular forces of attraction. That is why they have low melting point and boiling points. Next, metals have high melting boiling point, insoluble, can conduct electricity, because of mobile electrons, and they are malleable and ductile. You can read about malleable and ductile in your textbook lah. Don't waste my time. Okay, so this is how you answer chemical bonding question in exam or in your tests. Number 1, always state the structure. Number 2, describe the bond. Next, carbon disulfide, CS2, is a simple covalent compound. Okay, super easy question. They already tell us that it's a simple molecular structure, covalent compound. Blah, 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 blah. I don't care. Okay, CS2 has low boiling point. Simple molecular structure has a low melting boiling point. So it's true. Very simple. Okay, CS2 has a good electrical conductivity when molten. Let's look at the cheat sheet. Don't conduct electricity. Okay, so it's false. CS2 is very soluble in water. Let's look at cheat sheet. Simple molecular structures are insoluble in water. False. CS2 is a crystalline solid at room temperature. Low melting and boiling point. That means it's going to be a gas or liquid in room temperature. So the answer is false. So easy. Next, explain why graphite and carbon dioxide have different properties. 4 marks in O or N level. Super easy. Graphite has what I told you. Always number 1, state the structure, and number 2, describe the bond. Okay? Graphite has a macromolecular structure, that is state the structure, with strong covalent bonds, describe the bond. Hence, graphite has high melting point and boiling point, insoluble in water, good blah 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 blah. I don't care. These are basically all the things you need to study. Okay, next, carbon dioxide exists as small molecules. See? State the structure, and next we'll confirm B, describe the bond with weak intermolecular forces of attraction which are easily overcome. Hence, CO2 has low melting point and boiling point, and it cannot conduct electricity since all the valence electrons are used in bonding. Easy, right? Just follow the format that I give you. In summary, ionic bond is like your bond with your parents. They give you money, i.e. electrons, and you just take. Family bonds are strong. Ionic bonds are strong. Covalent bonds is like the bond with your besties. You guys share everything, including electrons. Bonds between besties are strong. Covalent bonds are strong. Intermolecular forces of attraction between molecules is just like the interpersonal forces of attraction between you and your ex. Very weak and very easy to break. That's why break up already. He or she became your ex. If you are smart, you will take a screenshot right now. You better screenshot now, because I've condensed all this ape logic into the best flowchart that your monkey brain can understand during your revision for your exams and tests. All you have to do is to read the flowchart, understand it, and follow the structure that I state over here. Easy, right? As you can tell by now, this cheat sheet is super good and super easy to use. This is the cheat sheet that your teacher actually owes you for a super easy full marks for chemical bonding in exams or tests. So everything is over here. You got ionic compound. State the structure, describe the bond. 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 And all the tested physical properties are stated over here in very easy to read format. I even highlighted the very important state the structure, number 1, and number 2, describe the bond. If with this cheat sheet in hand and you still cannot get full marks, then you better chemical bonding. Easy AF. Easy and fun. Now, go use the cheat sheet that you have just screenshotted and go get your full marks. Okay? Go. Faster, go get your full marks. Faster. What are you waiting for? Faster.